For lesson 2, we're just going to look at some examples of situational problems using a sinusoidal graph to demonstrate or to model the data. For a physics project, Morgan and Lily have to graph and analyze an example of simple harmonic motion. Morgan swung on a swing, and Lily used a motion detector to measure Morgan's height above the ground over time as she swings back and forth. The girls then graphed their data as shown. At the end of each cycle, the swing returns to its initial position, which resulted in a sinusoidal graph. Interpret the graph, which just means find the characteristics. So this is exactly what we did in the first lesson. So first we'll describe the range. So these are the y values that are allowed for this graph. So our maximum is 2, and our minimum is just less than 1, so it's divided into 4, so that would be 0.75. So the range would be 0.75 up to 2, inclusive. We can describe the amplitude and the midline. We'll do the midline first, actually. So we want to take our max and our min value and find the average. So 2 plus 0.75 divided by 2 would be 2.75 divided by 2, which would be 1.375. So then our amplitude is the difference between the max value and that midline, or the min value and that midline. So we can take 2, subtract 1.375 equals 0.625 is our amplitude. And this is measured in meters, so I should be putting the units. And we should write the midline as an equation, y equals 1.375. Okay, for the period, we want to describe how long it takes for one full cycle, which in this case is one full swing. So swinging from the midline to the highest point to the lowest point and back to the midline, or from a max point to a min point. So a max point to the next max point. So we'll go from here, which is 1.5, to the next max, which is at 3. So the period takes 1.5 seconds. And for part B, it's just asking at what height is she at when she is at the time 4 seconds. So after 4 seconds, how far away from the ground is she? So we can just look at the graph, go up right there. So at 4 seconds, she's 1 meter off the ground. Which we can write as a coordinate point, so 4 and 1. For our next example, a competitive gymnast's coach graphs one particular series of jumps. Describe the gymnast's jumps using the graph. So we're just going to describe the characteristics. So again, the range, we want to know what's the highest and the lowest point. So our units are the height in feet, and time is measured in seconds. So our highest point is 30, and our lowest point is 3. So we can describe that in words. The jump ranges between 3 feet and 30 feet from the ground. Okay, and our midline, so it'll be between those 2 points, 30 and 3. 30 plus 3 divided by 2 So she's in the middle of her jump at 16.5 feet. Our amplitude, so how high is she away from that midline when she's at the highest point? Would just be 30, subtract 16.5, 13.5 feet. And the period, which would describe how long does it take her to complete one full jump. So we'll go from the max point here to the next max point. Actually, those don't they don't line up nicely with the x-axis, so we'll use the min points. So we have from 12, the next min point would be at 15. So it takes 3 seconds to complete a jump. And example 3, Allie and Colin own a car and a pickup truck. They noticed that the odometers of the two vehicles gave different values for the same distance. As part of their investigation into the cause, they put a chalk mark on the outer edge of a tire on each vehicle. The following graphs show the height of the tires as they rotated while the vehicles were driven at the same slow, constant speed. What can you determine about the characteristics of the tires from these graphs? So our x-axis for both graphs is time, so they're just measuring how long does it take. And then the y-axis is the height of the tire in inches. And they would have used that chalk mark to measure this. So we can see that the car, the max height is 24. So that tells us that the diameter equals 24 inches. And for the truck, the max is 32. So the diameter of that tire would be 32 inches. Okay, so to complete one full revolution, so they would use that chalk mark and measure how long does it take to go around one full time. So let's look at the difference between the two periods. So we can start at 0. That's our max point. So at x equals 0, y equals 24, go down to the min and back up. It takes 1.2 seconds. For the truck, same thing, we can start at y equals 32, down and all the way up. It takes 1.6 seconds. So the period for the truck is 1.6 seconds. So that means it takes longer for the truck to do one complete revolution than it does for the car to complete one full revolution. So it's traveling further, the truck is, in less time. So that would account for the difference in the odometer reading. At this point, you can do practice 2 in your textbook or in your practice booklet.